Hi everybody, welcome to Math in Space. Typically when you think of math, you think of the math that we use here on Earth. However, today we're going to take a look at the idea of the math that you would use up in space. So far, you've been learning about the science of space. For example, how we got the rovers to Mars and the possibility of human civilization one day on Mars. Math is a very important tool that we use to collect lots of information about planets that we haven't been to. And hopefully it will lead to one day us actually landing on Mars. For example, are you aware that your weight changes on different planets? So, if you looked at Mars, you would actually weigh less on Mars than you do on Earth. Let's take a look at why. Your weight is based on the amount of gravity of a planet, and the gravity of each planet is different. For example, Earth has a gravitational pull of 9.81 meters per second squared, while Mars has a gravitational pull of 3.71 meters per second squared. So due to a smaller mass, the gravity of Mars would mean that you are 62% lower in weight on Mars than you are on Earth. But that's not the only thing that's different about the planets. Can you think of something else that might be different? How about age? Your age is actually based on the amount of time it takes for the planet to spin once, which is measured in a day, or the amount of time it takes to go around the sun once, which is measured in a year. That's different for every planet because every planet is a different distance from the sun. So that means that the farther away a planet is from the sun, the longer it has to go around the sun, which means the longer a year is. Here's an example. How long is a day on Earth? Well, we all know it is about 24 hours. But for Mars to complete one full rotation, it takes 24 hours, 39 minutes, and 35.244 seconds to go around once, meaning that's one day. A day on Mars, which is sometimes called a sol, is actually about 3% longer than on Earth. And the length of a year on Mars is different than that on Earth. For example, the time it takes Mars to go around the sun once is 687 days. However, on Earth, it only takes 365 days. To start, let's take a look at how these numbers are different on each planet through different equations. We're going to take a look at the Viking mission and the Curiosity mission that both went to Mars. Graphs are very important things that we need in both math and science. We use them to collect data and organize data so that way we can better understand it. In this example, we're going to take a look at the data that was collected from the Viking mission. It talks about the surface temperature of Mars. When reading a graph, it's very similar to reading a map. The x-coordinates would be like going east and west, where the positive numbers go east and the negative numbers go west, where the y-coordinates on a map would be north and south. The positive numbers go up and the negative numbers go down. So how do we use this? Well, when you're trying to find something in an area, you need 2 points, an x and a y. Using those 2 points, we can tell exactly where something is at. That's called an ordered pair. We take the first number of the pair, which is the x value, and we go on a graph east and west, or right and left. And we take the second number, which is the y value, and we go up and down, or north and south. So what that means is, let's say we have an example like 3, 8 as an ordered pair. You would go 3 to the right because it's positive, and you would go 8 up because it's also positive. So if somebody gave you those coordinates on a map, you might say it's 3 miles to the east and 8 miles north. Not only do we use this information to locate, for example, the position of a rover, but we can also use it to determine how steep a hill is on another planet. So think about how important that math information would be on a planet like Mars. It can provide scientists with all kinds of information, like what kind of vehicles humans might need whenever they get there to explore the planet. So now, let's start to compare and contrast Mars and Earth to find out how they're different and similar. The first thing we're going to look at is the volume of each planet. The volume tells us how big the planet actually is. In order to calculate the volume of each planet, you need to know the equation for the volume of a sphere. The equation we'll use to find the volume of a sphere is V equals 4/3 pi r cubed, where V stands for the volume, r stands for the radius of the planet. Remember, the radius is half the diameter, or how long the planet is across the equator. Pi, in case you've forgotten, is also represented by 3.14. So, as we continue to explore Mars, the next thing we're going to look at is surface area. And you're probably thinking to yourself, well, what's surface area all about? The surface area of a planet is actually how much room on the planet we have to live. And you can calculate that in different ways. But again, be careful. There's surface areas of a flat surface and of a sphere. And remember, as we just said, a sphere is like a ball. So the formula that we're going to use is 4 pi r squared. And remember, r stands for radius. Now you're probably thinking to yourself, why is this important? Well, it's important because when we look at the surface area of a planet, we want to know how much space there actually is for humans to settle. So if we get there one day, how much room are we actually going to have? We also want to know because if the polar ice caps on Mars melt, that is the ice that's built up on Mars, if it melts, is it going to cover the entire planet? Are humans going to even be able to survive? These are all questions that we want to know before going there. So as we continue to explore Mars, there's another famous equation that you're going to use. And that equation is the Pythagorean Theorem. The Pythagorean Theorem is a very famous equation that involves a right angle in the triangle, which is an angle of 90 degrees. The equation is a squared plus b squared equals c squared. The a and the b can be interchangeable, and they're sometimes called the legs, or the sides of the triangle that connect to the 90-degree angle. The c is actually the side opposite the 90-degree angle, and sometimes called the hypotenuse. Sometimes builders use this to make sure that when they are constructing a floor, that their angle is a 90-degree angle. It's called the 3-4-5 method, where the 3 is in one direction, the 4 is in another direction, and the 5 is the opposite of the right angle, or the hypotenuse. And as we know, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So that means 9 plus 16 equals 25, and therefore they have a right angle. So you're probably thinking, how does this relate to Mars? Well, builders on Mars need to know that so they build their structures right. But also we can use it to determine how far away we can get from a home base or a base of operations and still see it on the horizon, which might be very important on Mars so you don't get lost. So remember, as you continue to explore and prepare your colony, here's a few of the formulas that you might find helpful. And these are just a few of the ways that math can help scientists prepare to get humans onto Mars. And who knows, maybe one day you'll even be on Mars.
To download the free lesson plans to be used with this program, visit us online at wqed.org/SOS. To request a hard copy of the lesson plans, please contact your local school district. Funding for this program is provided by the Pennsylvania Department of Education for Learning at Home.